Hello everyone. We're going to be finishing chapter 2 in our class by having a discussion about density. Now again, density is usually a topic that you guys should see when you're studying science in middle school, but we'll do a quick review of it anyway. When we refer to the density of an object or substance, we're talking about the amount of matter packed into an object or substance per unit volume. And what this translates into mathematically, right, if we actually read the definition and just sort of translate into a math equation, density equals the amount of matter, and the amount of matter can be described by measuring the matter's mass, and it's per or divided by volume. So density is mass over volume. And usually when we have these density problems, especially the very basic elementary ones, normally all of the variables that you need to solve the problem are included right there within the problem. So for example, I have a block of magnesium in this sample problem that I've put on this slide, and it has a mass of 42.9 grams and it has a volume of 25.38 centimeters cubed. They're asking for the density, and so this problem just involves plugging in the mass, which is 42.9 grams, and I'm going to divide by the volume. So let me plug in the volume. That's 25.38 centimeters cubed, and if I do this math, I end up with a density of 1.69 grams per centimeter cubed. Now, density ends up being important because usually it's possible to identify a sample of matter partly based on its density. So if I happen to have a block of metal and I'm not sure what it is, but I'm able to measure its mass and its volume and calculate its density, and I end up with a density value of 1.69 grams per centimeter cubed, then that implies that perhaps the metal might be magnesium. And so that's how density is used in the chemical laboratory. And the other thing I wanted to point out about density is, again, note that it is a ratio. It's one number divided by another. And this ties in very nicely to the conversation that we've had about dimensional analysis now for the last couple of tutorials. Since density is a ratio, I can use it as a conversion factor to solve problems. So, for example, all right, suppose that I have a substance, in this case it's acetic acid, all right, and I don't know the mass, but I know its volume. The volume of the sample of acetic acid is 655 milliliters. Well, what I can do is set it up like a dimensional analysis problem, 655 milliliters. Here's the density, which I said I'm going to be using as a conversion factor. Okay, now recall how dimensional analysis works. I'm going to multiply by a ratio. The ratio should have units of milliliters in the denominator so that they cancel with the milliliters in my given information. Based on the density value that I was given, for every 1 milliliter of this material, there is 1.05 grams of that material, of the acetic acid. If I do that math, then basically I end up with 687.75 grams per milliliter, but remember our rules of significant figures. Basically that volume that we were given, 655 milliliters, has 3 significant figures, so that means I have to round my answer to 3 significant figures, meaning I have to stop reporting the number right there. The 7 that is immediately to the right of the place at which I want to round is greater than 5, and so that means I would round this up to 688 grams. Okay, let's do another one just to make sure you guys have the hang of that. Okay, suppose I have turpentine. Okay, turpentine's a paint remover. And I'm told that I have a sample that has a mass of 345 grams. They want me to find the volume. Okay, so once again, if I'm going to do this by dimensional analysis, I'm going to take the given information, 345 grams. I'm going to multiply by a conversion factor, the density. Okay, there's my conversion factor. And I need this conversion factor to have grams in the denominator so that they cancel with the grams in my given information. That means I'm converting to milliliters, which will be the numerator of my conversion factor. Based on the conversion factor that I was given, there are 0.870 grams in 1 milliliter. So if I do this math, basically I should get 397 milliliters once I round properly and take into account the rules of significant figures. Now, as it turns out, density can be a little bit tricky to measure because, again, remember, density is mass divided by volume. And finding volume can be tricky if I don't have an object that has a regular geometric shape. If I have a cube, all I have to do is, cube the sides or multiply the sides of the cube by each other to get the volume. If I have a sphere, right, then there's a formula for the volume of the sphere that I can use as long as I can measure the radius of the sphere. But suppose, like in this case here in the picture, I'm trying to measure the volume of this rock, and as we all know, rocks aren't always perfectly geometric in their shape. This rock has a very irregular shape. Well, what I can do to fix that for myself is to measure the volume of the rock by displacement. So basically the cylinder over here on the left is sort of the before picture. I'm going to put in some water to a specified volume in the cylinder. Then I'm going to go and introduce the rock into the cylinder, and that's going to make the water level rise. So now the water level is up here. If I take the difference, if I subtract these two volume measurements by each other, then I should get the volume of the object overall. So suppose that we incorporate that into a density calculation. Right? How would I go about doing these calculations? Well, let's take a look at this particular problem and see how I would make that happen. This problem tells me that I have a graduated cylinder that I initially had filled to 125.0 milliliters with water. Then I'm going to add an irregularly shaped object like that rock we were talking about at the top of the slide, and it has a mass of 324 grams. And once the object was submerged, meaning it was completely covered with water in the cylinder, then the water level rose to 141.8 milliliters. So what is the volume of the object? Well, the 125 milliliters is the water only. The 141.8 milliliters, that's the water plus the object. So if I subtract the 125 milliliters from the 141.8 milliliters, then I should have the volume of the object by itself. So this would be 141.8 milliliters minus 125.0 milliliters. If I do that math, I should get 16.8 milliliters. Now they're asking for the density of the object. Well, we just calculated the object's volume in the previous step, and I was given the mass of the object within the text of the problem. So all I would have to do is evaluate the density formula with these two measurements plugged in. So that would be 324 grams, and I'm going to divide that by 16.8 milliliters. And if I do that, then I should get 19.3 grams per milliliter. Okay, so we're going to do some more of these problems tomorrow and discuss this further. If you have questions over what you've seen in this tutorial or any other questions related to this topic or the topics that we've been discussing over the last couple of tutorials, again, feel free to email or speak to me in class tomorrow. I will see you guys and have a good night.